Okay, 2.4 complex numbers and operations. So, solving a quadratic equation using the square root. So if I have x squared minus 16, I set it equal to 0. And then what?
X squared equals 16.
So x squared equals 16.
Square root.
Take the square root.
And it's 4. X equals 4.
Plus and minus 4. Because negative 4 squared is also 16. Okay, so that's how we would do it if we had a difference of squares. Or we could factor it to x minus 4, x plus 4, and set both of those equal to 0 and get x plus or minus 4, right? Okay, what about b? X squared equals negative 9. Take the square root.
X equals.
What's the problem?
Plus minus 3.
That's a negative.
It's a negative. Have you always been told you can't take an even root of a negative number?
Yeah.
Yes, until today. Okay, so what we have here is the square root of negative 1 times the square root of 9. The square root of negative 1 equals I. Square root of negative 1 equals I. So I get plus or minus, what's the square root of 9?
3.
3. And the square root of negative 1 equals?
1.
No, square root of negative 1, I. So it's plus or minus 3i. Okay, this is called an imaginary number. We cannot graph it. It's in the complex number system. We need these because a lot of electrical work in the process of working on equations, they found square roots, fourth roots, even roots of negative numbers. And you can't just say, oh, doesn't work, doesn't exist. So they had to find a way to work with it. So the square root of negative 1 equals I. I is a placeholder. Okay? It's not a variable. It's a placeholder. It's a placeholder for negative 1, or square root of negative 1, excuse me. So, x squared equals negative 5.
So, square root of x squared equals square root of negative 5. And then do
So, well, plus or minus.
plus or minus.
And we're going to have the square root of negative 1 times the square root of 5. Can we find the square root of 5? No. Not without a calculator, right?
Yeah.
So square root of 5 and then I. The imaginary part, which is the I, needs to come last. You notice how I close my square root? I do that so I know what's in it and what's out. So try the next one on your own.
I forgot what time one equals stuff.
Don't forget your plus or minus. Okay, so 72 can be split up to negative 1, 9, 4, and 2. Yes? 72 is 9 times 8.
Yep.
So I'm looking for perfect squares because that's what I'm taking the square root, right? And 8's 4 times 2.
Yep.
So the square root of 9 is 3. The square root of 4 is 2. What's 2 times 3? 6. And you're left with a 2. And what is the square root of negative 1? I.
Okay.
Why do you just decide to do that though? Like, what gives you like the idea to just do that? I just want to know. Like,
What do you mean?
Like, wait. What gives you the idea? Right. Hold on.
We did this earlier in the year.
I don't remember person. No, like, is it just because it's not like how a perfect square root, so you just do that, or?
Yeah,
Okay.
you got to break it down.
But like, since 5 stays the same, because nothing like multiplies.
Right, 5's 5.
Okay.
And I was looking for perfect squares. Like, I could have gone down to 3, 3, 2, 2, and 2, but that just is annoying to me.
That's too much.
Yeah, stop at your perfect squares. That's why you know them. Okay, so we have to be able to evaluate it. We already know that the square root of negative 1 equals I. So write that on the top. Square root of negative 1 equals I. We're going to write these underneath it. So write it again. Okay, so now I squared. Well, I squared would be, well, the square root of negative 1 squared, wouldn't it?
Mm-hmm.
Well, what happens when you square a square root?
Um,
Don't you get what's inside?
yeah,
So the answer is what?
-1.
Negative 1. So I cubed would be I squared times I, wouldn't it? If I split it up into what I know. Because 2 plus 1 is 3.
Do you have to split it up?
Well, I'm showing you why it is what it is. Okay, so what is I squared?
I squared is -1.
Negative 1. And I is just I. So I cubed is negative I. You're not allowed to leave any power of I greater than 1 in your final answer. That's why this is important to know. So I to the 4th, well, if I break it up in what would be easy, would be I squared times I squared, wouldn't it? Because 2 plus 2 is 4. Well, what's I squared?
-1.
Negative 1. So it's negative 1 times negative 1, which is what?
+1.
Positive 1. So what? I only went to the 4th, and I said any power, right? What do you? I to the 5th. What's going to happen?
So be 1.
Be I to the 4th times I, wouldn't it? Why do I want to go I to the 4th? Because it's easy, isn't it? It's 1.
Yeah.
Well, I to the 4th, which is 1, times I would be I. So what's happening? Is it going to start over?
Yeah.
Yes.
Why did you put negative I for
That's
cube?
On I cubed,
Yeah.
I put negative 1 times I.
So it would just be negative I.
Uh-huh.
There's too many I's.
Okay, so we have the 1st, 2nd, 3rd, and 4th. You cannot have anything in a final answer over 1. It just revolves. So the way you do this,
5.
the easiest way, 5 just goes back to 1. 6 would be negative 1. 7 would be negative I. 8 would be 1. 9 would be I. 10 would be negative 1. 11 would be negative I. 12 would be 1. Okay, so what if I ask you I to the 476? Actually, 776, evidently. That's a lot, right?
Yeah.
But I said it revolves, yes? What's the one we want to have? 1. We want 1, right?
Mhm.
So the way we do exponents, could we break it up and see, like, what if I divided this by 4? So that would give me I to some power to the 4th, right? Because a power to a power is multiply. And then I would have some remainder over here. And my remainder then is going to tell me my answer. So let's see. So 4 goes into 7 how many times?
Once.
Once. Carry a 3. 4 goes into 37 how many times? 9. With
37? Oh, 4.
Yeah.
So I thought it was 30.
with 1 left over.
4.
4. So is there any remainder? No. So I could put a 0 here. That's fine. Because anything to the 0 power is what?
0.
No.
1.
1. So this would be 1. Well, this was divisible by, this would be, oh, I put these in the wrong spot. Sorry. Fix this. To the 4th, to the 194th. Sorry, I put it in the wrong spot. Because I to the 4th is what?
1.
1, and 1 to any power is still what?
1.
1. So the answer to this is just what? 1 times 1, which is 1. So any number we want to do. Guys, give me one. Make it an odd number.
36. 5. 35.
35? You're going to make it easy.
Exactly. I don't want to do it any harder than that.
Put the 7 at the end. 355.
3,350.
There.
Oh.
Okay. So all we're doing is dividing by what, guys?
4.
4. We can divide by 4. So you go I to the 4th, and then we're going to have to some power, and then we're going to have I, and then the remainder. Well, I know there's at least going to be 1, right? Because it's odd. Okay, so 4 goes into 35 how many times?
8.
8. With 3 left over?
Yeah.
4 goes into 35? 8. 4 goes into 37?
9.
4 goes into 29.
9. No. What am I doing?
7. And what's your remainder? 1?
Yeah.
Okay, so this whole thing is just 1. Because I to the 4th is what?
1.
1. And 1 to any power is 1. Okay, what's I to the 1st? Negative 1. So the answer is negative 1. So the 4 you have to know are what?
2, 3, 4.
1, 2, 3, 4. Okay?
Yeah.
Okay, an imaginary number is BI, has a coefficient. A complex number is a real number and an imaginary number. The real number always comes first. A complex number is a real number and an imaginary number. We are going to treat, I told you it wasn't a variable, but we're going to treat it like a variable when we do math with it. So it has like terms. Make sense? You can make any number a complex number. If I had 7, that's a real number, yes?
Yeah.
But what if I do plus 0i? Did I change it from being 7? Nope. But did I make it a complex number?
Yeah.
Yes. So if you're on the computer and it says write your answer as a complex number and you get 7, you should put what behind it? Plus 0i. Or you get an answer of 4i. That's just an imaginary number. So to make it complex, we have to have 0 plus 4i. Because complex numbers have real and imaginary. Okay? Negative 6 plus 4i. 7 minus I square root of 2. Technically, this should be 7 minus the square root of 2i. Your imaginary number, your imaginary unit, should always be at the end. That's why knowing where your square roots start and stop is really important. I will tell you when I'm working.
The red members that are allowed to go to the elementary to get activities set up for this afternoon. Oh, dismissed. You need to report to the west side of the building where you load buses. Please go out the door on the side of the media center, the north side. should be a list in the announcements that shows who can go. Please report to the west side of the building, the bus loading zone.
Sometimes your
We've
voice
got
is
the
just
door on the
annoying.
north side.
Just like,
Okay, I will tell you when I work with this, if I'm doing a math, I probably put my I in front, but your final answer, make sure it's where? In the back. To make this a complex number, what do I need to put in front of it?
0 plus.
Okay. Okay, add and subtract complex numbers. Like I said, it's like terms. Add the real parts, add the complex. Or combine the real, combine the complex. So the sum of 4 minus 7i and negative 11 plus 9i.
2, 11, 6, 5, 4.
What?
I don't know what I just said.
4 minus 11.
7,
Negative 7. And positive 9 and negative 7.
2, I.
The next one. This one.
Negative 6 plus 3i.
Negative 6 what?
Plus 3i.
Minus 3i.
Oh, yeah.
Makes sense, guys? Okay, what about difference? What does difference mean?
Subtraction.
Subtract. So it would be 6 plus 8i. These first parentheses, do they mean anything? No. Minus 2 minus 5i. What do you need to do with this negative? Distribute it. What do you think is the biggest thing you guys will forget?
Not to distribute.
Okay, so you'll get 8 plus 13i. So
I'll forget that.
what's the next one?
Okay.
The negative 1.
No.
No.
What are you forgetting to do?
Distribute.
What do you?
So you want that in addition? Add them together technically.
Well, you're combining.
So that'd be addition.
No, combine is add or add or subtract. So this would be a positive 4 and a negative 1.
So that'd be 7.
7 minus 3i. What's wrong, Dylan?
Okay.
You good?
Yeah.
Okay.
Hurts my brain too.
Okay, what do you think happens when I multiply?
Same thing.
The same thing. Okay, so negative 2.5i times 8 minus 9i.
Yeah, I get it.
Okay, so 8 would be 40, so carry a 4. 16 plus 4 is 20. So 20i. Oh, how about a negative, right?
Yep.
A negative and a negative is a positive. And then 45, carry a 4. 18 plus 4 is 22. And I times I would be, okay. But I said you can't leave any power of I, Carson, put your feet on the floor, greater than what in your answer?
1.
What is I squared?
1.
Nope.
Negative 1.
Negative 1.
Oh, look.
So we now have 22.5 times negative 1. What's that make it?
Negative.
Negative. And it also needs to go in the front.
Yeah.
So negative 22.5 minus 20i. Okay, 2/5 I times 10 plus 5/2 I. So 5 goes into 10 how many times?
Twice.
2. So 2 times 2 is?
4.
So I have 4i.
Yeah.
And then, well, 2/5 times 5/2 is not just 1. And then I times I is, can I leave it like that?
No.
Nope, because what is I squared?
Yep.
What is it?
Negative 1.
-1. So it's -1 plus 4i.
Yep.
Okay, so try these two on your own.
Okay, so,
Just foil them to start.
I don't like this game anymore.
Why can't you get rid of those 2 R's?
Because one's positive, one's negative. The sixes
The I's.
on the second one,
Yeah.
because one's positive, one's negative. So it's positive 1, negative 1.
Doesn't that like cancel it out?
Yeah, zeros out. They're gone. I just didn't cross them off.
Okay.
Oh, you thought they were still there. Sorry. I thought
Yeah.
you were asking me why I got rid of them. Okay, did you guys get 13 and 17 fourths?
Yeah.
Why did that happen? What's special about these factors?
They're, the, one's positive, one's negative.
The difference in squares, yeah?
Exactly.
Okay, they have a special name now, and they're called complex conjugates. And you noticed when I multiplied by them, I didn't even have an imaginary number left, did I?
Nope.
I had a real number. So, if 3i is a factor, negative 3i is a factor. If negative square root of 5i is a factor, positive square root of 5i is a factor. Because it came from taking x squared and taking the square root of something, so it's always plus and minus. So those conjugate pairs always exist because we have a real number system. We don't start with an imaginary number system. So the example of complex conjugates are 7 minus 8i, 7 plus 8i. Negative 2 plus I, negative 2 minus I. What sign do you notice changing? Is the leading sign changing? No, it's the sign in the middle. If the leading sign changes, your middle term will not zero out. The middle term should always zero out. Now, x plus 2 and x minus 2 are conjugates of each other, but they're not complex conjugates. Why aren't they complex conjugates?
Because there's not an X.
Oops.
There's,
There not that there's not an x, there's not an I. And there's not an imaginary number included.
Oh, yeah.
So, here's my moral of the story. I go through this lesson, and for the entire year, when I want people to say conjugate, they say complex conjugate. Okay, that's wrong. Unless it's an imaginary number is included, it's not a complex conjugate. But could I call these just conjugates of each other?
Yeah.
Yeah. It's like I can't call every rectangle
I knew you were
a square, but can I call every square a rectangle?
Sure.
Yes. So if you're going to remember one word, the one word you're going to remember is conjugate. What makes it a complex is the I, the imaginary part. Okay, and we're done for today.